All right, guys, our lesson 9. Try. Share your answers with me, or you quickly get it done. What is your answer for 1.3.5? 1.3.5. I am waiting. I have x equals to 8. Is somebody else confirming that answer? And even if you are doing it now, guys, it takes you less than a minute to get these marks. X equals to 8 again. All right. Now, x equals to 8, correct. However, I told you to always be careful when you see a 2 on top here. Can I write this as, so please always take note of that. That thing can be written as x 1 over 3. You see, once I can write it like that with a squared, I told you to be very careful. Now, what do? Multiply by 1 over 2. Once I'm multiplying by 1 over 2, it's the same as if I'm looking for the square root. It is plus or minus. That is where the problem is now. So this is plus or minus 2, which means x 1 over 3 equals to 2, or x to the power 1 over 3. Now what do? I multiply by 3 over 1. And x will be equal to 8, or x equals to negative 8. So you need to be observant, otherwise you would keep losing solutions. So again, this morning we lost a solution. This is difference of 2 squares. I told you yesterday it is difference. Once I see a 2 on top there, and we can confirm. Let's confirm our answer quickly, and then we start moving very fast from here. If I want to confirm my answer, look at it. 8 to the power of 2 over 3, or 4. What if I say negative 8? Do you see? Still 4. So please be always careful. Be very careful. You are losing answers. I should have 2 answers, not 1. So it is difference of 2 squares. Another way that I could have done this, look at this. I could have done this way. X to the power 1 over 3 squared minus 2 squared. Do you see that? And that will give me 2 bracket. Once I have that, plus 2. Do you see what we have? equals to 2, or, and I told you because this one is the exponent is an odd number, I would definitely have an answer. So please go back to yesterday's lesson and rewatch. All right, 1.3.6. All right, because it is an odd, definitely would have an answer by multiplying by 3 over 1. And this is 1 times 3 over 1. So x will be equal to negative 1. And that would be correct. Guys, are we okay? Are we all right? I want us to move quickly. So please be careful of that particular one. Once I see a 2 on top, or even if it's a 4, because an examiner can give you something. Look, if I give you x to the power 4 over 3, that 4 there is a problem, because I could write this as x2 over 3 squared. Now you see where we're going. Once I have that 2 as a squared difference of 2 squares. So it's always to take an answer away from you. It's dots. So here, x to the power 2 over 3 would be equal to plus or minus. All right? 2 to the power 2, I've already multiplied by half. And then you can continue from there. Please, it is very, very important. Because when you say half times half, it means the square root. Look, let me write this there for you. Please put it down in your note. Put this down. All right. The power 1 over 2 is the same as square root. And we did this earlier. When solving and you introduce a square root, you see I said when solving a root, it comes with plus or minus. Only when you are solving. Only when you are solving. So please, I'm stressing that because it is very important. It will go, when you go to trigs, you're going to have the same thing. So the power half is the same as a square root. When you are solving and you are the one introducing a square root, you must introduce it with plus or minus. So every time I have to multiply with a half power, please bring in plus or minus. Are we okay there? And ready to move on? Okay. All right. This one here, we did something like this yesterday. These are disguised trinomials. 1.3.7 x to the power 1 over 2 minus 2x to the power 1 over 4 minus 3 equals to 0. Already I know now that I can write this as 1 over 4 to the power of 2 minus 2x to the power 1 over 4 minus 3 equals to 0. Okay. I can bring in the k method. All right. Or I can open, let me show you something different this morning. I can open 2 brackets instantly. And then I once did this. I dropped that there. I once did this a while ago. So this becomes x to the power 1 over 4, x to the power 1 over 4. I can go there straight. Once I have it in this form, look at the form again. 1 over 4, x to the power 1 over 4, x to the power 1 over 4. And I have a squared. It's like saying k squared minus 2k. What do? You put a k here, you put a k here. I can jump to this. I want you to start seeing that. And my product 3 and 1, I want a negative 2, so it's 1. Lovely. So what do we have? X to the power 1 over 4 equals to 3, or x to the power 1 over 4 equals to negative 1. Here, what are we going to get? We multiply this by 4. So x equals to 3 to the power 4. and here, no solution. Why no solution again? That is even. If it is even, our answer must be what? Answer must be a positive. Yes. Let me hear you.
Good morning.
Why
do you say there is no solution?
So,
if there is no solution, I got one.
You got one. Okay.
Yes, sir, yes.
All right. I know why you got one. You did this, right? You did this to the power of 4, right? Okay. Let's try something together. Let's try something together. Are you ready? Who am I speaking to? Who am I speaking to?
Lusanda.
All right, Lusanda. Let's put in 1 as x. Or let's try 81 first. 81 to the power of 1 over 2. Just, I want us to work together. All right. Minus 2, so that you would see what I'm talking about. Let's see if you are correct this morning, Lusanda. 1 over 4 and minus 3. All right, so 81 is correct. Now let's put a 1. Let's put a 1. Okay, if I put a bracket, doesn't matter. Do you see that it's not 0? So,
Yes, sir.
very, very important. When you have an even exponent, your answer must be a positive. Please. So, that is no solution. Okay, today I think I'm going to just teach you something on logs. Let's run. I'm going to teach you something on logs quickly. All right, next one. 1.3.8 x to the power 2 over 3 minus 3 x to the power 1 over 3. Okay, can I write this again? X to the power 1 over 3. All right. Oh, I can write it with a squared. Minus 3 x to the power 1 over 3 minus 4. That's a trinomial. Instantly, I don't even need K method anymore because I see what's going on. What do I drop in here? I drop that and I drop that. Because if I'm foiling, do you see it's going to be x to the power 1 over 3 squared. Now what do I want? 4 and 1. Minus and plus. X to the power 1 over 3 equals to 4. Okay, Lusanda, I want you to see this one. This one, I am going to have a solution for both of them. Why? Okay, for the first one here, what do? We multiply it by 3 over 1. This is 4. 1 times 3. What would that be? 64, I think. Because 16 times 4, 64. Yep. What about this one? Look at the difference between these two. In fact, I love these questions. This one, do you notice, is an odd number. Odd power. So answer will either be a plus or a minus. So x to the power 1 over 3 times 3 over 1, negative 1, 1 times 3. This one, I want us to test it together quickly. I'm going to block your view, guys, just 1 minute. I want us to test. We're getting a negative 1. Will a negative 1 work and will a 64 work? Quickly, then you would write 64 to the power 2 over 3. All right, minus 3. I have 64. So you can always do a check also before you move on to the next question. Let's see, minus 4. All right, 64 works. Then I also got a negative 1. Let's go check. Will a negative 1 work? Do you see? So this should actually make you see the powers of the even power and the powers of the odd powers in terms of your answer. Please let me know if I've been able to clear. I love this because we have an even exponent, we have an odd exponent on the same page. Please talk to me, everybody. This needs to be very clear. When it's an even exponent, I'm expecting my answer to only be positive. But when I have an odd exponent, then I am expecting both positive and negative. I hope it's okay, guys. I hope it's okay. Algebra, very, very interesting part of maths. Okay. I'll also teach you, before I go into Surds, I'll quickly take you on some grade 11s, something you must know on logs. Very important. Okay. Oh, we have so many here. Hoo la la. Okay, let me duplicate this page. 1.3.9 3x to the power 3 over 4. Oh, interesting. We can divide by 3. Let's see, if we divide by 3, let's see what we will get here. Okay. However, okay, lovely. We can divide both sides by the x. What are we going to get? x3 over 4 divided by x1 over 4 equals to 8. Does that make sense? And when we are dividing with the same base, what do? We subtract. So 3 over 4. So this is basically, let me write this out. x3 over 4 minus 1 over 4 equals to 8. 3 minus 1 is 2, and that is half. Beautiful. Now check again. X to the power half. What do? We reciprocate. It's not plus or minus. We only put plus or minus if you are multiplying by half. But now I am multiplying by 2 over 1. What is x? 64. Are we on the same page? Test quickly. You can test. Always learn that habit of testing. It's going to assist you. Guys, do you notice I'm not using calculators all along? I want you to train yourself to that point. 64 then use your calculator. Don't run to your especially now that you are not at school, you're working at home. Try. Let's use you are smart. You are smart. X is 64. Ooh, what is this giving me? 67.88. Ooh, okay, let's go check. 67.88. All right, what if I change the right hand side? Will I get 67.88? Yeah, perfect. So when you're at home right now, not under pressure, please try to put the calculator aside. Use your brain. Develop your capacity to work. Some of you, even to write your name, you want to write it with a calculator. You're not helping yourself there. Okay. All right, let's look at 1.310. X. Oh, beautiful. I already see that this is, check, x to the power half. Because if I multiply half by 2, I'll get 1. So do you see again, it's another trinomial. Now I know it's a trinomial. I can quickly open my bracket. I drop the small exponent. Lovely. Now what do I have? 5 and 1 minus and plus. Beautiful. So x to the power 1 over 2 equals to 5, or x to the power 1 over 2. Already I know now here there's no solution. And I'm sure you understand why. Here, what do? We multiply by 2 over 1. It's 5 to the power 1 times 2. So what is x? I'm sure you understand the no solution part. Awesome, everybody. We're good? All right, great. 1.3 point. Guys, I'm moving quickly because I want to get into Surds. 1.311. So you are, when we are done with this work, I have put all of this in a playlist for you. Please go back January to school well ready. Watch these lessons over again. Relearn. Okay. All right. What would I do here? 2 to the power x minus 2 plus 2 to the power x plus 2 to the power x plus 1. Okay, let's see something. Let's split it. This is 2 to the power x times 2 to the power negative 2 plus 2 to the power x plus 2 to the power x times 2 to the power 1 minus 52. What I notice quickly is this, guys. The way you write is important. Write neatly. I see that that is common. Oh, so if I pull that out, what do I have left? 2 to the power negative 2 there, plus 1, plus 2 to the power 1. But only there. Oh, I can move the 52 over. Beautiful. So 2 to the power x. This is, I don't want to use a calculator, please. 1 over 2 squared. I'm using the laws of exponents. And 1 plus 2, can we just change it to 3? Let's learn without calculators. We only use it when necessary. All right, this is 2 to the power x. Some of you cannot even do this one now. Already you are stuck here. You want to run to your calculator. We want to try. We want to learn how not to. I am adding fractions. I taught you to use diagonal denominator. So what does that mean? Okay, look at my diagonal. Start from the top. 1 times 1 is 1. Then my next diagonal, 4 times 3 is 12. Over, then the last d is my denominator, 4 times 1. It's so beautiful to work without a calculator. It's so nice. So what do you have? 13 over 4. So what do I do here? This becomes 52. If I cross multiply, the 4 is going to multiply and the 13 will divide. It's beautiful to work without a calculator. What is 52 divided by 13? Okay, you can use a calculator, but I know it's 4. Yeah, 4. All right, so that gives me 16. 2 to the power x equals to 2 to the power 4. Therefore, x is 4. X is 4. I told you you can always quickly confirm. All right. 4 minus 2 is 2. Then 2 to the power 4 plus 2. 4 plus 1 is 5. So this is 2 to the power 5 minus 52, 0. Are we okay, everybody? This was something you should have done at home, so I'm not moving too fast. It's just it is very, very important, guys. It is very, you need to be ready for maths. All right, I think I have one more, then we go to Surds very, very fast. I have one more, then we go to Surds. Can you see, guys? No calculators, we just enjoying maths. Some of you, 1 plus 1, you use a calculator. Please, let's start developing ourselves. Oh yeah, I'm done. We have 3 questions. Oh, we're done. Okay, can I quickly, before I go into Surds, I promise to quickly show you something. For grade 11th, this isn't, just know it. And for grade 12th, you are going to definitely apply it. All right, solving exponents using logarithms. For those in IEB, this is part of the syllabus. For DBE, we just pass through this, but it's important that you know it. And it's not so difficult. If A to the power B equals to X, then B will be equal to log. I'll explain this. All right. Where X must be greater than 0. I'll show you how this works quickly, but I wanted to write this down, and that's the whole formula. We can find the value of B, and this is what I want you to notice. A here is a base. When it comes to log, it will also be a base. So whatever is the base on the exponent side is also the base on the log side. Log is logarithm. I'll show you. Okay. FYI, log x base A can also be written as log x over log A. A log without a written base is called a natural log. And its base is 10. Now, this is actually very important, guys. When we do acid and base right in grade 11, this is going to come in. So it's better we know it now. Yes, it's important. This comes in acid and base, grade 11. Yes, so it's important. So let's take a bit of time. Log x base A can be written as log x. So what I'm saying is log x is the same as log base 10x. But we don't write the 10. It's a natural log. And I'm going to show you on your calculator what all of this will do. Are you ready for me? So I can use this to solve questions where I cannot convert to an exponent. All right. Examples. Let's look at examples quickly together, everybody. Example. And then again, you would see what I was trying to show you earlier on. Example. Given that x to the power 2 equals to, oh no, let me do this. I'm looking for the exponent. 3 to the power x equals to 27. I'm sure this you can do normally because we can write 27 as a base of 3. Okay, so let's do it in 3 ways. Because I can write this as a base of 3, therefore x. All right, great. This is what we know from grade 8, grade 9, grade 10. So please know we are going to do acid and base, and log will come in. Okay, but I can try to use logs. Check. When do I use logs again? When the variable, I needed to have added that. Please find somewhere and add just this line for me. Use logs. Let's put that. Use logs when the exponent is the variable. Use logs. Again, we will do it in functions. We will do it in financial maths. So it's good that we know it now. When my exponent that I'm looking for is a variable. So I'm looking for x at the moment. And x is a variable. Oh, so I can bring it in. Let's bring it in. X, therefore, can be written as log. That 3 is a base. We put it as a base. 27. Now grab your calculators with me, everybody. Please, and keep your eyes on the screen. Grab your calculators. Look at your calculator. If you look at your calculator, there are 2 logs there on the right hand side. There is one that is just written log. Lusanda, why is your screen blank again? Quickly log out and log in. I'll wait for you. 30 seconds. 30 seconds, quickly. I don't want you to miss it. Your screen cannot be blank. We're waiting for you. 30 seconds. You have 20 left. I need to see you log out and log in. Lusanda, I'm not seeing you log out. Others, do you have your calculator there? Can you find log for me? Yes, Lusanda, your hand is raised. Are you fine now? While I'm speaking to Lusanda, guys, I'm waiting for your response. Can you find logs? Yes, Lusanda?
So please can you repeat what you said? Do I say shift and then that's how I find log?
No. Don't press anything yet. Don't press anything yet. I'm just saying, guys, can you find log? There are 2 log buttons on your calculator. You're not pressing shift. There's one on the right hand side, just under the on button. It says log with 2 blocks. Press that for me. Log with 2 blocks. Can you see? It looks exactly like what we have right now. Now let's type in the block beneath. The base is 3 and we have 27. And that's all you do. What's your answer? 3. Done. Did you get that, everybody? Did you get that? So the base is the base, and that's it. We're done. Now the other one that I wanted to show you is, look at this. X can be written as log 27 over log 3. You see, the base goes to the bottom. The 3 is the base. It goes to the bottom. Now, which log am I using here? You find the other log, so division line. That log has no block. It's just log 27. Find it. It's the second log. You see, it has no base. It's a natural base. And your answer is still 3. Are we on the same page, everybody? So I can use this if my number is not something I can write. And that's all about logs for now. There's more, but for now, it means I can solve this. I can solve this. You want to try? I can solve it now. Because 9 cannot be written as a base of 2. But I know there's a cheat for me. I can solve it. You want to solve it for me? Everybody, you're going to get a decimal. Share your answer. I just need somebody to share answer with me. Somebody show you the answer. 3,169, 3,17. Oh, you guys are good there. Let me check if you guys are correct. X equals to log. I like this one, so I'll use this one. Just one log. All right. We go into our calculator quickly. And we have that log. The base is 2 and my number itself is 9. Oh, 3,1699. Beautiful. 3,17. Lovely. You would see if you were to try your answer, you would get approximately 9. 2 to the power 3,17. Do you see that? 9.00. You learned something in grade 11. What about the next one? You want to do that for me quickly? Yes, you must get an error because I told you that remember, x equals to log base 2. This is where the problem is. The rule says that must be greater than 0. That's the error. Must. Not even 0. So no solution. Even if you try this, 2 to the power x, if you put this in your calculator, you'll still get an error, no solution. All right, because that value must be greater than 0. Error. Okay, all right, that was a quick lesson on log, so we can apply it from grade 11. Like I told you, you'll need it in financial maths, so you're going to use logs. For me, when I do financial maths in grade 11, we do it. Why? You'll be doing something like A equals to P, 1 plus I, and you need to look for N. So what do? Divide both sides by P. All right. Now, if I'm looking for n, do you see n is an exponent? Oh, so I'm going to bring logs in. 1 plus I and a over p. Very, very important. And you'll also use it for those of you that are doing physics. When we get to acid and base, we are going to give you pH. Negative log that hydronium ion concentration, and then you'll be told to find your hydronium, but that will do when we get to a physics session. Okay, so these are two places. Can you see my logs playing a big role? That's why it's important for us to have an idea of what logs are. We'll also use it in functions in grade 12. So these are applications of logs. All right, but anyway, we're good. Surd simplification. Let's run quickly. This one would not take us very long. Surd simplification. Surd simplification. Now, I told you what a surd is. A surd is when you have a square root. Okay, so rules. Rules. Root of a times root of a will be root of a times a. Okay, a squared. And this simply means a to the power 2 and square root is half. So our first rule is this. Root of a times root of a is a. Rule number 1. I only demonstrated how that came to be. So root of a times root of a, I pick a root, a times a, which is a squared. But root itself means to the power half. 2 times half would give me 1. So root of a times root of a is a. Root 5 times root 5. Check. 5. That is number 1. Number 2, root of a times root of b is root of ab. If the roots are the same, I can pick the root and multiply the number. So for example, so that's my second rule. We don't need any explanation there. Root 2 times root 3 is root 6. Note, root a plus root b is not, please, this is not correct. Root a plus root b, or let me put a plus or minus, because somebody would say, okay, if it works for times, root a over root b is more like exponents. Example, root of 9 over root of 16. Now, this we can do as simply 3 over 4, right? Let's see if it's going to give us the same. All right? I could have written this as root of 9 and root of 16, or even it's the other way around, you know. The square root of 9 is 3 and 4. So please take note of rule number 3. I can split it. I should have written it the other way around, but it's fine. Root of a over b is the same as root a over root b. Root of ab is the same as root of a times root of b. Number 4. Number 4. Rationalizing roots. Now, when we say rationalizing, your calculator will never allow you to have a root as a denominator. Roots are not allowed as denominators. That's why if you punch a root in your calculator, check something here. 1 over root 2. Your calculator would solve it, because that's your calculator will not allow. Your calculator will not allow that. So how do I rationalize? We rationalize to remove we rationalize to remove third denominators, and it's very easy. 1 over root of a becomes, now look at what you do. You multiply by the surd itself, because root a over root a is 1. So we have not changed the question. I hope that makes sense. Root a over root a is 1. We have not changed. Now if I multiply, what is 1 times root a? It is root a. Now what is root a times root a? It is a. So we have removed the surd as a denominator, and that is called rationalize. Your calculator will not allow you. So we call it rationalization. Let's try a few, 2 sums here, or 3. I'm just waiting for you to finish writing. We rationalize. Okay, so what do you think 1 over root 3 would be? What is 1 over root 3? This would be 1 over root 3 times root 3 over root 3. 1 times root 3, root 3. Root 3 times 3, 3. You can check on your calculator. You would see that you are actually as smart as your calculator now. You are actually as smart as your calculator now. Do you want to try this for me? 2 over root 5. Quickly try it without a calculator, please. Without using a calculator. Are we done? I need more hands. I need more hands. I've seen a few. Okay, so what would you do? 2 over root 5 times root 5 over root 5. And what would this be? 2 root 5 over 5. Can we check on the calculator if we are correct? 2 over root 5. All right. What about this one? Let's try one more. 2 over 3 root 2. What will this give you? We have 2 more things to look at, and then we'll be done on this one. Very short. Give me a thumbs up once you're done. Can somebody unmute and give me an answer? Somebody just unmute and give me an answer. Anybody? Don't be afraid of your answers. I'm sure you're checking on a calculator if you're right, so just let me know. Sizwe, Confidence, Lusanda, Letabo, Mimi, Madekwi. Yes, Lusanda, I'm with you.
Sir, I didn't need a calculator. My final answer is 6 square root 2 over 1. I don't think it is.
6 root 2 over 1. Okay, let's check. Let's check if you are correct. So, all right, look at what I will do. I only want to get rid of, so I'm only going to multiply that. That is 2 root 2 over root 2 times root 2. That will be 3 times 2. And my answer is root. How did you get 6? Lusanda? Okay, maybe you did this. Let me work. I think this is what you did. But maybe you didn't simplify well. Check. You must have done this, right? Now, 2 times 3 would be 6 root 2 over 3 times 3 would be 9. Root 2 times root 2 would be 2. All right. And then if you do that, you would notice 2 here, 1, 2 here, 3, 3 here, 1, 3 here, 3. So you probably did something wrong while you were simplifying. And let's confirm. 2 over 3 root 2. Lusanda, are we on the same page now? And thanks for sharing your answer. I love it when you share your answer. It just makes it nice for me. That's how to learn. So others, please, you don't have to be correct to share your answer. You're sharing your attempt. Are we okay though? Did it make sense? Let me give you one more to do for me. What is your answer? 5 over 2 root 3. Are we done? So you don't need to really multiply by the 2. You're just getting rid of the root. So all I need to do is to only multiply. It's simpler that way. By the root 3 and the root 3. So I have 5 root 3 over 2 times 3, which is 5 root 3. I hope you see where my 3 came from. Root 3 times root 3 is 3. Let's confirm. 5 over 2 root 3. All right, 5 root 3 over 6. Are we good with this, everybody? Any question? Let me know, please. Okay. Well, like I said, we have 2 more things. That was number 3, or that was number 4. Now, number 5. Let me do this first before I go to simplifying surds, before I go to number 6, the 6th concept. Look at this. We're going to need a perfect square. All right? root of a squared b. What would this be? I want you to please follow me closely here. If I have something like this, and I'll show you where I'm going to get this. This is the same as saying root a squared times root b. This was law number 1. But what is the root of a squared? It is a. Okay. I know you are a bit lost somewhere. I'm going to find you now. I will find you. Mimi. Okay, 1 second. You multiplied by... Mimi, why would you multiply by root 5? The root here is 3. Mimi, talk to me quickly. You multiplied by root 5. No, you multiplied, the root here is 3. The one at the bottom is 3. Let me know if we are clear. Are you talking about number 4? Mimi, please multiply by the root. Even if you got the same answer, you're going to complicate things. Multiply by this one. That's the aim. You want to get rid of that. Okay. You're going to complicate stuff. All right, guys, look at this. Where do I need this? This is important. For example, if I ask you for the root of 32, root 32 is not a perfect square. Right? So I'm going to break 32 down into something that will give me a perfect square. Check. What is 32? It is 16 times 2. Going back to grade 7. Oh, 16. I can actually find the square root of 16. What's the square root of 16? 4. So this answer is 4, then root 2. Can we check on a calculator if my magic is correct? Are we okay? Did you see what I did? So you simplify. You simplify. Let's try a few more. What about 8? 8 is not a perfect square. So when you break down 8, you're going to break it down into a perfect square and a number. Check this. I can write this as 4 times 2. Yes, I know the square root of 4. It is 2. Then I bring my root 2. Because basically we're saying this is something as root of 4 times root of 2. And what's the square root of 4? 2. And then I have my root 2. Write that quickly. I know some of you would cheat here and use your calculator. Remember, we were trying to develop ourselves. So you need to start thinking quickly now. What is root 75? Perfect square. 25 times 3. Oh, what's the square root of 25? 5 root 3. Are we on the same page there? So you must know how to find, but sir, when you say 8 is not a perfect square, when we say a perfect square is a number that will give you a whole number. when you find its square root. For example, 16 is a perfect square. Okay? So what you are doing there is you are breaking down 8 into factors. You see, 8 can be written as 2 squared. This is factors, not square. So if I put a root there, you see that it becomes 2. Sorry. I hope we're okay there. What about 80? Try that for me. Break down 80. You can use your calculator to find. But I wanted to work in a way where we don't use calculators. You guys are lazy thinkers. Many of us are lazy thinkers. Because if an examiner asks you to show the steps, you would lose marks for using calculators. So if I were you, if I want to use a calculator, I'll just use a calculator to find the factors. For example, 80 equals to shift fact. Okay, I don't have shift fact on my calculator here. But you know how to find the factors of 80? If you press shift fact on your calculator, you get 4 squared times 5. Or you get 2 to the power something. But I know 80 can be written as 16. Square root of 16, 4. Are we okay there, everybody? All right, we look at the last point. Point number 6. So you've got to learn to do this and practice. We have just a few questions on this. Point number 6. Conjugates. All right. The conjugate is simply the sum, but a change of sign. The sum, but a change of sign. The conjugate of A plus B is simply A minus B. The conjugate of A minus B is simply A plus B. So we just change the sign. A plus root B, conjugate A minus root B. Root A minus root B, what's the conjugate? Root A, so that's what remains. I hope that makes sense. Oh, okay, wait. Let's see something. 10 and 8. Lusanda, let me go back. Guys, just pause quickly. Let me show you something. If you cannot think of perfect squares, good. Thank you, Lusanda, I actually forgot to show you something. Look at this, 10, right? I don't know the perfect squares, but what is coming to my head is 10 and 8. These are not perfect squares. Beautiful. But do you notice I can break 10 down into 2 times 5? And I can break 8 down into 4 times 2. Right? So I'm trying to break it down. Simple stuff now. Now check. Already I have a perfect square there. 4. Oh, 2 times 2, another 4. What is that giving me? 4 times 4 times 5. What's the square root of 4? 2. Another square root of 4? 2. but I don't know root 5. 2 times 2, 4 root 5. It's just longer. It's just longer if you cannot think of a perfect square. It's just a little bit longer. A little bit longer. Let's try another one. But you will still get it. Let's try one more. Let's see something. I'm just thinking of a number quickly. So you don't have to think of, even if you cannot think of the perfect square, you can still manage through. I'm just doing a quick calculation in my head. Ta-da-da-da-da-da-da-da. All right, let's look for something that is big. Let's look for something that is big. Yes, Lusanda?
Can we do 144?
Sorry?
144, so can we use that number?
But 144, that's 12. It's not even so that's 144 is a perfect square. All right. Maybe if you tell me 288. Oh, Zianda is saying, okay, Zianda says, Zianda, are you giving me 2 and 40 to work with? You want me to work with 2 and 40 for root 80? Zianda, is that what you're looking at? Okay, guys, hold on with this 288. Let's go back to this root 80. Just keep that number at the back of your mind. Root 80. Okay, and what you can think of is 2 times 40. Fine. Break 40 down. Let's go ahead. What can you think? 4 times 10. Right? Break it down further. 2 times 4 times 2 times 5. What is 2 times 2? 4. So I'm looking for perfect squares. I already see that 4 is a perfect square. What's the square root of 4? 2. What's the square root of 4? 2. I do not know the square root of 5. It's not a perfect square. What do you have? 4 root 5. Make sense, everybody? Okay, let's go for that 288 quickly. Let's do more of this before we move to my number 6. Look, I can take you back to grade 7 and grade 8. 1, 4, 4. 2, 7, 2. 2, 36. Already I see that's a perfect square. But even if I don't see that, check. 3 or 2 can still go, right? 18, 2, 9, 3. You know what I'm doing, right? Okay, so this can be written as 2 times 2 times 2 times 2 times 2 times 3. Listen to me, my good learners. All I'm looking for pairs. I have 2 2s, I have 2 2s, and I have 2 3s. This is the way we used to do square root in grade 8. Can you see that? 2 2s, I'm looking for pairs. All I need to do is to pick one of each. Pick one of this, 2. Pick one of this, 2. Pick one of this, 3. And now I have a root that I don't know there, root 2. What is 2 times 2? 4. 4 times 3, 12. I'm just enjoying myself, guys. If you leave me on like this, I can just continue. And somebody that sees it already can actually look at 144. You see, the quicker you think of numbers, the faster you get it done. You can quickly think of 144 times 2. And what's the square root of 144? But even if you're not thinking of numbers, and the reason I like the breaking down is we can use letters and ask you to simplify. We can use letters and ask you to simplify. Are we okay, everybody? Do you want us to try one more? Want us to try one more? Let's try. Let me bring a big number, and we don't want to use a calculator. 432. Let's see, with 430, let's try with 432. Okay, quickly. 432. 432. 2 here, and then 16 there, right? Then 2 can go again. 108. 2 can still go. 54. I think 2 can still go. 27. All right, then I know it's 3 cube here. 9. 3 can go in 9. 3. All right, so this is the same thing as how many 2s? 1, 2, 3, 4. 1 times 2 there. 3 and 4 and 3 and 3 and 3. Can we pair them? This is basically grade 8. There we go. Pair that and pair that. You're working in pairs. Now pick one of them. 2. Another 2. Another 3. But the last one has no pair. Root 3. What is 2 times 2? 4. Times 3? 12. Is this correct? Root of 432. Yep. Not using calculators is just fun. Are we okay, everybody? I want to go to my last point. So please try to develop when you do this, you're actually developing your IQ. You're becoming more intelligent. You're tasking your brain more. And you find that, oh, so I can do this without a calculator. Good. And also save the battery of your calculator. Don't let it die on you the day you need it. Okay. All right, guys, let's finish up. I want to finish. Oh, I thought I was going to finish at 10, but awesome. Okay. When do we use conjugate? Now, please take note. Before I give you when. The product of a sum and its conjugate is a product of dots, of difference of two squares. What do I mean? A plus B times A minus B. We multiply the first and we multiply the last. A squared. It is that simple. The product of a sum and its conjugate is the product of dots, difference of two squares. A plus B, A minus B is A squared minus B squared. Conjugate. What would this be? Guys, once I see that it is the same but the signs are different, it's conjugate, I'll multiply the first and the last. Root A times root A is A. It's always a minus. Root B times root B is B. Can you see that my roots are gone? What will this be? So I have a sum multiplied by its conjugate. The conjugate is just a change of sign. What do? First and first, last and last, A times A squared. This is always a negative. Root B times root B is B. And I'm done. That is the way to get rid of your roots. So now, we are going to apply this. Quickly write down. Let me know if there's any question. Are we done, guys? And I hope it makes sense to us, right? So when we multiply a sum and its conjugate, we use the product of difference of two squares. But why is this necessary? Consider 2 over 3 minus root 2. Your calculator will not allow you to do this. Let's check. If I punch this in a calculator, won't it be the same? Oh, do you see your calculator automatically got rid of the root at the denominator? It completely. Now the examiner is going to tell you to get this same answer without you using a calculator. Let's see. What do we do? Look at what I'm going to do. I am going to come here and say this can be written as 2 over, but how do I get rid of this? To get rid of this, I'll have to multiply by its conjugate. But I don't want to change the question, so I'll repeat this on top. Do you notice I have not changed? Because I can cancel this is 1. Gives me back my question, but we don't cancel. So I multiply the top and the bottom by its conjugate. Oh, already. What does this mean? This is 2 into bracket 3 plus root 2 over 3 minus root 2, 3. Oh, beautiful. Now what do? I distribute. 2 times 3 is 6 plus 2 root 2. Now let's deal with this one. Because it's product of difference of two squares with its conjugate, I can simply multiply. What is 3 times 3? 9 minus root 2 times root 2 would give me 2. Oh, that is how my calculator got the 7. That is how my calculator, let me compare my answers again. That is how my calculator got the 7. Ah, beautiful. 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 Let me know. We are finishing now. Once we get this one, then we cool. We only have about 5 questions to work out on this, because I've done a lot of examples here to make us see. Let's try one. Do you want to simplify this for me without the use of a calculator? Quickly. Then we have one or two, we have some examples to do, or activities, and we will call it a day. 2 minutes is fine. Do we have answers? Okay, what do we do? 3 over 2 plus root 3 times 2 minus root 3. All right, for simplicity, 3 into bracket. You can skip this step, but for now, I want to do it so that we see what's going on. What do? We multiply in. 3 times 2 is 6, minus 3 root 3, over, now, difference of 2 squares, 2 times 2 is 4, minus 3. Oh, this is 6 minus 3 root 3 over 1. Can we confirm this? Let's confirm this. 3 over 2 plus root of 3. Beautiful. Did you guys get that as well? Did you guys get this as well? Do me a favor, just quickly in the message on the chat here, just type I'm okay. Just type I'm okay. Quickly, I want to see if everyone is okay. Then we just answer a few exam questions and then we end the session. Just want to know if everybody's okay. Thank you. All right, I'm seeing a lot of I'm okays. Just want to make sure everybody's okay. All right, keep coming in. Beautiful. All right, I need a few more. I need a few more. Thank you. All right. So these are now exam questions. You see, these are level 1, level 1. Do you want to try the first one for me? By the way, it's without the use of a calculator. Without the use of a calculator. Oh, also, please take note, if I tell you root 2 plus root 2, these are like terms we can add, because like saying k plus k, 2k, right? So take note of that. These are just common sense of maths. Okay, you want to try this without the use of a calculator, please? I'll give you how many minutes for both questions? I want you to just try. 3 minutes? Yeah, fine. Were you guys able to finish? We're just marking now, so we're going to increase the pace. All right, root 18. Let's start from there. So it is root 18 plus root 50 minus root 8. 18 is 9 times 2. You need to start thinking very fast. 50 is 25 times 2. And 8 is 4 times 2. So I can see my perfect square. The square root of 9 is 3. So this is 3 root 2. Square root of 25 is 5 root 2. And square root of 2. All of them, these are like terms. So 3 plus 5, 8 minus 2, 6 root 2. Let's confirm. So it's just addition now. Root of 18 plus root of 50 minus root of 8. Are we okay? All right, the second one, root of 132. So basically, yes, talk to me. Yes, Lusanda? Yes.
We can also use 3 times 6 plus 10 times 5 minus 4 times 2, right?
Okay, what did you say? 3
So I said
times 6
yes,
plus
10 times 5
minus. Okay, then what did you... But this will not, you have to change, you have to keep changing until you find the roots. Because what is the square root of 3? I don't know. What's the square root of 6? I don't know. So break them down into factors. What did you do from here? Let me ask. Lusanda?
So I also broke it down. I said 3 times 2 times 3.
All right. So 3 times 3 times 2, right?
Yes, sir.
And then here?
I said 2 times 5 times 5.
Okay. And then here?
2 times 2
times 2.
root 3, yes.
Okay.
Yes, sir.
It's good. It's only going to take you longer, and then we pair them, right? We look for pairs. Now I can pick the pairs. 3 times 3, I can simply write 3 root 2. 5 times 5, I can write 5 root 2. 2 times 2, I can write 2 root 2. Perfect. We're still correct. 6 root 2. Okay. So we can, but the more you do it, the quicker you start seeing, 18, 9. All right, but good job. Good job. Since we're working as beginners. All right, what about this one? Root 132 over root 3. You would notice now here, what do? We rationalize. But 132 times root 3. Okay. Can we break down 130? We don't want to use calculators, so let's be smart. Let's do it on the side. 132. This will be what? 60. No, I'm lying. 66. Oh, I see 33. I see 3. And I see 11. Okay. So 2 times 2 times 3 times 11. Okay, let me do this. Definitely we know this will be a 3. Okay, wait. Do you notice the top? I can combine it, right? 2 times 2. There's a 3. I'm bringing in the second 3 because I can combine it. Oh, I can now work with my pairs. So 1, 2, and 1, 3 would give me 6 root 11 over 3. Let's see, is this correct? I could do it in a shorter way, but I want to carry everybody along until we start seeing things better. But this is the simplified version, 2 root 11. Did that make sense to us? Please, when the examiner says without the use of a calculator, show all your steps. Don't just jump and say root 132 equals to, here you would get 0. If you just 2 root 33, you'll get a 0. They want to see your breakdown because they know that we can simply put all of this in a calculator and get an answer. Somebody who is familiar with numbers, I already see 132 and I see 12 times 11. And I see my 12 as 4 times 3 times 11. I can then multiply it by root 3. You see, the quicker you see the numbers, the faster you're going to get things done. I already see a root 4. I see a 3. I bring in the second 3. Now I already see a 4. What's the square root of 4? Is 2. 3. So the more you get used to numbers, the faster we're going to get things done. I hope it makes sense. So we're not restricted to one way, but just enjoy without the use of a calculator. Can I move to the next one? I think we have about 3 more slides to look at. Let me see. Ooh. Okay, I'm going to throw the rest for you as homework. Okay, quickly. 1.4.3 and 1.4. Oh, these are straightforward. We did this. Oh, okay, not so straightforward. I was looking at something different. Okay, yeah, still. You want to try 1.4.3 for me? Please look at the root very well. Look at the root very well. All right, let's mark quickly. We're getting hungry. All right, 1.4.3. Now, this is 5 plus 3. Now, this takes you back to the first rule I gave you. If you are multiplying, remember what I said, root A times root A or root A times root B. You pick the root and then everything under comes in. And you would notice that difference of 2 squares. This is 25 because, and that is minus. I can only do that if it is plus and minus. Root of 16. And this is what? 4. And that's not the only way. Somebody can decide to simplify first. Maybe some of you did that. Check. Some of you did that first. Root 5 plus root 3. Okay, even simpler. I went very complex. What is 5 plus 3? That's 8. So root 8 times root 2. And what would that be? Root 8 times 2. Root 16. So many ways of getting that done. I could still do something else, but that's fine. 1.4.4. Oh, look at this one. Root of 5 minus, this is what you call the product of conjugates. This one we did quickly. 25. Root of 5 times 5 is 5. Root 3 times root 3 would give me 3. Are we good, everybody? Without the use of a calculator. Okay. Product of 2 squares. Okay. Oh, beautiful. Let's do this one. And I think after this, we have 2 more to do. The rest will be done as homework. We have just 2 slides. Come quickly. Practice. Are we done here? Did we manage? What did I do? Okay, quickly let's mark. Root 48 minus root 3 over root 27. Such big numbers. All right, what I will do for me, I think to make life easy, I already see root 48 as 16 times 3. There's a mark for that. All right, if you want to break it down further, but look, like I said, the quicker you see these things, the better. What about 27? I see a 9. So I don't want to multiply big numbers. All right, check. What is the square root of 16? It is 4, so I have my root 3. Oh, do you notice these are like terms? Square root of 9? What is 4 root 3 minus root 3? It is 3 root 3. And this is 1. Is this the only way of doing it? Nope. Let's try something else. Let's try to bring in what I taught you earlier. Just going to be longer. So the more you see, the quicker you see these things, the better for you. I can do this as well. All right, I'll still get the same answer in case some of you did this. All right, check this. 48 times 27. All right. Obviously, I know this now would be 27. Okay, beautiful. Now, if I look at 48, we can break 48 down for those of you that want to break it down. If you want to break it down, you know what I'll tell you to do? Come to the side. 2 there, 24. 2 there, 12. 2 there, 6. 2 there, 3, 3, and 1. Do you see that? Okay. And so I know this as what? 2, but this is long, but I just want to show you that there's nothing to worry about. What about 27? It is 3 times 3 times 3 minus. I want us to enjoy breaking down maths. And this is over 27. Can I pair these things together? Let's pair. Let's look for my pairs. All right, I have got a 2 that is paired. I have another 2, that's another pair. Oh, I have a 3. Oh, beautiful. I have another 3. Oh, perfect. So, done. Look at this. Sweet, sweet maths. So what is this? 2 times 2. So this is 2 times 2 times 3 times 3 minus 3. The root is gone automatically now. What is 2 times 2? 4. 4 times 3. Or 4 times 9, that's 36. Minus 9. What is 36 minus 9? That's 27. So there's no need to cry out for a calculator. There are so many ways. Did it make sense? But the quicker you know your numbers, you see, somebody who knows the numbers on the left-hand side, they are done. So, and this will come with practice. With practice. All right, 1.4.6. I don't know if you want to write that down, but 1.4.6 we are foiling. I don't think that should be much of so much work to do. I'm just trying to see, maybe there's someone who's writing. All right, guys, this is not difference of two squares. This is foiling. I hope you remember how to foil. A plus B squared is a squared plus 2ab plus b squared. That you must know quickly. You know, we're now in grade 11. So I take the first one, I square it. 2 times 2 is 4. Now look at the middle. I multiply the 2 and multiply it by 2 again. So 2 times 3 root, that will give me 6, times 2 would give me 12 root 32 plus, I hope that makes sense. I'm multiplying the 2, 2 times 3. All right, that gives me 6 root 2, then multiply by 2 again. Then the last one, 3 times 3 is 9. All right. And root 32 times 32 is 32. Okay, let's see. 4. Now, 32 is a problem. I think we can break it down. 16 times 2. And what is 9 times 32? That's 18. That's 27, 288. And what will this give us? 4 plus 12 times 4 root 2 plus 288. What is 4 plus 288? That is 292. Yeah. Plus 64 root 2. No, not 64, 48. 48 root 2. Let's check on a calculator what this would give us. Open bracket, 2 plus 3 root 32. Close the bracket, squared. Oh, all right. Check. In an exam, and you want to check, and this is not, look at the answer you're having. You're having 359.88. I'm going to check if my answer will give me the same. Don't forget 359.88. Then I'll tap my own answer as well. 359.88, so I'm correct. That's how you check decimal answers. Are we okay, everybody? Are we good? All right, the last slide for the day, and then the rest will be homework. We have one more session to consolidate everything, but look at this one. Let's simplify this one. I'll give you 5 minutes to try. There's no joy in me doing it without you being able to do it. 5 minutes. All right, did you manage to get me an answer? Talk to me, people. Did you manage to get me an answer? Okay, let's mark together quickly. All right, root 32, let's break it down together. You have to show all steps without the use of a calculator. This is 16 times 2, 9 times 2, 3 root 3. Okay, so we're trying to go the shorter way. 108, all right, beautiful. So 108, 2 will be 54. 2 would be what? 27. Okay, look, I have a perfect square there quickly. 9. The idea is to get perfect squares. So this is what? 2. You see, I have perfect square, another perfect square. 2 times 2 is 4, times 9, times 3, and 8 is 4. Don't just jump to 2 root 2. You will have used a calculator. I hope that makes sense. Now, what is 16? Square root of 16 is 4 root 2 minus 3 root 2 plus 3 root 3 over 4 times 9 is 36. And what's the square root of 36? 6 root 3. What's the square root of 4? 2 root 2. We are trying to simplify. What is 4 minus 3? That's 1. So that is root 2 plus 3 root 3 over 6 root 3. Now the numbers are smaller. Did that make sense to us so far? Did that make sense to us so far? The numbers are now smaller. So we're just trying to work out small numbers. All right. Now we can look for the conjugate. Root 2 plus 3 root 3 over 6 root 3 plus 2 root 2. What do we multiply by? You are focusing on the denominator because that's where the job is. Conjugate. So here what do we do? This is foiling. This times that. That will be 6 root 6 because root 2 times root 3 will be root 6. This times that. Because it's not difference of two squares, guys. I hope you see the difference. All right. This would be minus. Root 2 times root 2 is 2. Times 2 is 4. Plus this times this. Root 3 times root 3 will be 3. 3 times 6 is 18. So we have 18 times 3, and that will be 54. Positive times negative is negative. 3 times 2 is 6. And I have a root 6. Oh, interesting. Because my 6 root 6 would then cancel each other. Now here I have my difference of two squares. The first, remember these are conjugates. So 6 times 6 is 36. Root 3 times root 3 is 3. And that will give us 108 minus 2 times 2 is 4. Root 2 times root 2 is 2. Okay, so what do you notice? And 54 minus 4 is 50 over 100. Wow. Let's check. 1 over 2. before you start writing corrections, let's check. Root 32 minus root 18 plus 3 root 3 over root of 108 plus root of 8. 1 over 2. So your answer, guys, you should be able to see from this lesson that you are capable of doing a lot of things that you guys use your calculators for. You are as smart as your calculator. You just don't believe it. You've not been told, and you don't express and practice. That's all. But you are as smart as your calculator. Okay. Did it make sense? Wonderful lesson today. It's been more than 2 hours. I didn't anticipate that, but all good. We learned. I'm going to send you a couple of pictures, and this is where all the homework would be. Okay, so I'll start from here. This is going to be our first homework. I'll send you this one. So please take note. Don't worry about, or I think let's screenshot. I want you to be responsible. We can't spoon feed you. This is grade 11. So let's start from here. Homework number 1. So all the other homeworks, I've added them together here. So we're going to consolidate. Screenshot every page. I'm going to spend 5 seconds. So let's distribute the screenshot. Somebody takes the first one. Somebody takes the second one. Don't let's wait for everyone should be part of it. We go. Oh, beautiful. Next. And remember, it could be more than one person taking a particular page. Next. Let's keep sending through. Okay, guys, I'm not seeing anything on my side. I hope you guys are taking pictures and then you send later, please. Next one. This is a lot of work now. You're going to have like 4 days or 5 days to get through this. This we would answer maybe next weekend. Because it's a lot. I want you to engage yourself, please. Holidays for work, for those who are serious. This is what separates the distinction people and just the ordinary pass. Next one. For those of you that are ready to work, those of you that wanted the 90 questions, this is where it begins. Next. 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 It's a lot. This is for serious people. Somebody's already tired. Oh, this guy. Just take 1 slide per day. You'll be fine. I think this might be the last one. Let me push this up a little bit. 1 second, because this one. Let's check if it's the last one. Oh, that's it. That's the last one. Remember, this is the whole of algebra in term 1 for grade 11s, whole of algebra. Grade 12s, you're not going to do algebra anymore. Teachers are done. It is for you to keep practicing. And so once we mark all of this together, we'll then start our registered extra class. And that, with the registered extra class in January, we start with trigonometry. Okay, all of this will be marked this year. Start telling your parents about it. Start making inquiries. Just send a message to the office and inquire about the extra class. You can also download the Crazy Physics Study app, which will allow you all of these lessons you would find in the study app. Okay, make sure you also follow. Lots of lessons are going on, and that's our social footprint. Okay, ladies and gentlemen, I've taken your weekend on a good start. Have a beautiful, beautiful weekend, and see you on the group. Goodbye. Thank you, guys. All right, bye. Thanks for the clap. Thank you for the hululations. Thank you for the vuvuzelas. Goodbye.